Hi, I had problem number 7 in problem set 4, and problem number 7 reads, there exist positive integers a, b, c, and d, and with no common factors greater than 1, such that a log base b of 3 plus b log base b of 5 plus c log base b of 11 equals to d, where b equals 185,625, that's lowercase b. Find a plus b plus c plus d. So to solve this, we're going to need to simplify this portion of the equation down. That was horrific. Okay, so to do that, we're going to use law of logarithms. First thing we're going to do is take each coefficient and make it an exponent in the argument of the logarithm. So we're going to have a log base b of 3a plus log base b of 5b plus log base b of 11c equals d. We're going to need to further simplify this down using another law of logarithms. Because each of these logs have the same base, we can then combine all three into one logarithm by multiplying the arguments inside the logarithm. So log base b of 3a times 5b times 11c equals d. So now to solve this, you're going to take b to the d power equals to the argument. That's how you solve logarithms. The base to the answer equals the argument. So b to the d power equals 3a times 5b times 11c. So now we're going to plug in lowercase b here. So b equals 185,625. So to the d power equals 3a 5b times 11c. Now we're going to use prime factorization to hopefully get this number down into these three prime numbers. So we're going to move over here and write down 185,625 and divide that by 11, and that equals 16,875. This number is not divisible by 11, so now we're going to divide it by 5, and that equals 3,375. Again, we're going to divide this number by 5 now to get 675. This number is still divisible by 5, so now we have 135. Again, it's divisible by 5, 135. So we have 27. Now, this is no longer divisible by 5, but it is divisible by our other prime number, 3. And that equals 9, and 9, of course, is 3 squared. So now we have 7 numbers that equal 7 numbers when multiplied equal 185,625, and all of which are prime numbers, and all of which are the 3 prime numbers we are looking for. So we have 3 3s, 4 5s, and 1 c. So if you look over here at the problem, a would equal the amount of 3s we have, b would equal the amount of 5s we have, and c would equal the amount of 11s we have. So we're going to write that down here. A equals 3, b equals 5, and c equals 1. So now we have to solve for d. I wrote this down incorrectly. It's b equals 4 times 11 to the 1 power equals 185,625. Now, because we just factored this out to get these numbers, we know that 3 to the 3rd power times 5 to the 4th power times 11 to the 1 power is going to equal 185,625. So the only logical thing d could equal is 1, because anything to the power of 1 is going to be itself. So that means d equals 1. Now if we look at the original question, we're supposed to find a plus b plus c plus d. A plus b is 7, plus c is 8, plus d is 9, and that is your final solution, 9.